All right, folks, it's back in action here. In this video, we're just going to cover two quick topics. We're going to look at adjacent angles and the definition of them and how to identify adjacent angles. And then we're going to look at angle addition postulate. And the reason why these two are closely related is because we need to understand adjacent angles to also understand how angle addition postulate works. And adjacent angles are going to come into play in the very next section, section 1.5. All right, let's take a look at our definition of adjacent angles and break it down into all of the key parts. There are many key words in this definition. Okay, so it's going to be two angles. The angles are going to share a common vertex. Okay, that's important. They are going to share a common side. And then they are not going to have any common interior points. So when you think back to all of the vocabulary in the previous video, common vertex is that shared endpoint. The common side, the sides are going to be these rays of the angle. And then the interior points, we briefly talked about interior and exterior, and interior points are going to be anything in this area. Okay, so now looking at this, what we want to notice in this picture is that there are three angles in this picture right now. We have angle YU. Actually, I can't name it with three letters because I don't have another point on here, this angle 1. Then I have this angle 2. And then I also have, it's easy to overlook it, but we also have this big angle right here. Okay, so there's actually three angles in this figure right now. Now, the angles, notice that all three angles share the same common endpoint. So any two angles that I would choose here would satisfy this part right here, this common vertex. If I look, for example, at this green angle, angle YUM, and this red angle right here, I can see they share the common vertex. They share this common side right here. However, they do share these interior points. The inside of the red angle is also inside the green angle. So what we can say is that angle 1 and angle YUM, we have to name it with three letters here, those angles are not adjacent. Okay. We could also say the same thing about angle 2 and angle YUM. Those would also not be adjacent angles for the same reason. Angle 2, the blue angle, and the green angle, they share the vertex, they share a side, so they meet these two requirements, but the interior points of angle 1 are also inside angle the green angle YUM, so they're not adjacent. In this figure, the two adjacent angles are actually angle 1 and angle 2 are adjacent. Those two angles, adjacent, sorry, got distracted as I was talking. Angle 1 and angle 2 are adjacent because they satisfy all the requirements. They share the common endpoint, they share this side right here, and the interior points of angle 1 are completely separated from the interior points of angle 2. Now, that being said, once we can identify adjacent angles, we can understand the angle addition postulate. And this is going to work just like segment addition postulate, okay? So this is going to be very, very similar to the segment addition postulate, except for it's going to be angles instead of segments. So just like with segment addition postulate, we're going to add together two angles. We can see this right here. I've got two angles added together and it will equal a whole. It can only be two angles, it can't be more. And then just like with segment addition where the two segments had to be connected, our two angles here will need to be adjacent, okay? So the two angles will need to be adjacent angles. The key word that we're going to look for if this was written as a word problem is the word interior, okay? So I've got two adjacent angles here, and we can see that this point P is on the interior of angle RST, RST, so this point's on the interior. And since this point is here, I could draw in this ray, creating the common endpoint and a common side, dividing this angle into two angles. Notice the two angles are not the same. That means that angle PSR, that's right here, so angle PSR, that's this one, and angle PST, that's this one, will add together to give us the whole angle of RST. Okay, so we can see those add together. Now we're going to try to draw a picture over here real quick. Our keyword that we're going to see is interior, and what we would draw first is the angle ABC. So you're just going to draw any old angle. I'm going to call it A. Remember, the B has to be the vertex, ABC, and then it tells us that R is going to be in the interior. So I can just put this point R anywhere I want on the interior, and then I'm going to connect it and make a nice ray. What that's going to do is it's going to divide this into two nice little angles. Now, I could write it as angle ABR, so I could say the measure, remember we're going to put the M's there, of angle ABR plus the measure of RBC, the measure of angle RBC, is going to equal the measure of the big angle. So the two small angles will equal the big angle. So we're going to say the measure of angle ABC. Now, I personally feel that this is a lot of letters, and this gets really, really confusing for me. My brain jumbles those letters pretty frequently. So I'm going to call this little angle 1, and I'm going to call this little angle 2, and I'm going to rewrite this as the measure of angle 1 plus the measure of angle 2, make sure you're including those M's, equals the measure of angle ABC. And for me, that's a whole lot easier to see. And our reason is going to be angle, addition, we're going to abbreviate, add, postulate, and we're going to write it as this little post, okay? When we get to class, we're going to do some actual examples and apply this idea, but for right now, I just need you to get comfortable with all the vocabulary.